Hello and welcome to this question and answer session on questions on irrational numbers, where we're going to be looking at 10 sets of practice questions and 10 sets of scenario-based questions using irrational numbers and exact values. Okay, so let's get started with question 1. Okay, so question 1 says, which of these numbers is irrational? Root 25, pi, 0.5 or 7 over 2. Okay, so root 25 is 5, so that's definitely not irrational because it's got an end. Now pi is famously irrational, so I do know that the answer is pi, but 0.5 isn't irrational because it stops, it's got an end, and 7 over 2 is 3.5, so not irrational either. Okay, right, let's look at question 2. Which of these numbers is irrational? Okay, so it is going to be, well, I'll do it by process of elimination. 9 over 3 is just equal to 3, so that's fine. Minus 4 is just minus 4, so it's finite, it makes sense, that's fine. So it's not this one, that one's fine, this one's fine. 0.2121, okay, right. This is a recurring decimal, so it does go on and on and on, but it's rational because we can predict what's going to go. After the 2 becomes a 1, after the 1 is a 2, after the 2 is a 1. We know what's going on with this, so it's a rational number. So we're absolutely fine with that. Recurring decimals are not a problem. So this one here is going to be root 65. Now, root 65 is irrational. 64 is the square number, so root 64 wouldn't be irrational, but root 65 is. Let me just grab my calculator here, and I will just show you why it's irrational. So here we go, 65 square root, let's see what happens. Here we go, we've got a bunch of numbers that make no sense. So after this 2 is a 2, but after this 2 is a 5. After this 7 is a 7, and after this 7 is a 5. So we don't actually know, we can't predict what number is going to come after the next one. So therefore, root 65 is an irrational number. So let me just move that back away and we'll continue on. So here we go, root 65. Question 3 says, which of these numbers is irrational? Okay, well, I'm not going to waste our time. Well, actually, I will. So 12 isn't irrational, that's fine. Root 3 pi is irrational. Anything to do with pi is going to be irrational, no matter what, because it doesn't matter what you multiply pi by, you do not make it rational. Okay, it's still going to be a long list of numbers that may or may not contain the answers to the universe. Right, root 16 is 4 over 3. This number here would be 1.3333. Now, although the 3's go on forever, they are rational because we know what they're doing. And then here, we've got 9.5, which is rational as well. Okay, so question 4. Which of these numbers is irrational? Well, it is going to be, it's not 10, it's not 19, it's not a third. This is 0.33 recurring. That's the closest to being irrational, but it's not. It's going to be this 4 times root 2, because 2 isn't a square number, so the square root of 2 is going to be weird. Here we go, let's see what it looks like. Root 2, there we go. 1.4142135. You can't predict what's coming after the 4s. You can't predict what's coming after the 1s. It's completely irrational. Okay, right, so there we go. Now, if we times this by 4, by the way, just to show you, it doesn't matter. It's still going to give us something irrational. It hasn't made any more sense. This time we don't know what comes after the 5s or the 6s. Okay, so there we go. Let's move that to the side. An irrational number. So here we go. Last one here for this page. So which of these numbers is irrational? Well, it's going to be this one, pi over root 3. Root 4 is 2. Root 0.16. Now that is going to be 0.4. Let's just have a look though. 0.16, because obviously it's not obviously a square number, but it is a multiple of a square number. So that's 0.4. I'll put that down here. And then 4 is just 4. There's nothing irrational about 4. It's a square number. So yeah, so here we go. We've got our solution here with this one here, pi over 3. Right, question 6. let's have a look here. The perimeter of a square is given by perimeter equals 4 times side length. Find the perimeter of a square with side length root 10 centimeters. Give your answer as an exact number. Okay, so they want us to do 4 times root 10. Okay, well 4 times root 10 is just 4 root 10. We could work it out, but they want it as an exact value. So when they say they want their number as an exact value, they just want you to leave it as is, okay? So they don't want you to work out this, they don't want you to round it. Because if we did do that, one second, if we could do it here, 4 times the square root of 10, we could get this here. But as you see, what we'd have to do is we couldn't feasibly write down all of the numbers, because although the calculator has only shown us these digits here, these numbers would just continue on forever and ever and ever. So at some point we would have to round our answer to this question, and therefore our number would no longer be exact. So the only way we can give our answer as an exact value is to give it as a multiple of the irrational number. Okay, so that's what this is, 4 root 10. So let's have a look here. The circumference of a circle is given by circumference equals 2 times pi times radius. Find the circumference of a circle with a radius of 7. Give your answer as an exact number. So what we do is we plug in the numbers that we can. We've got 2 times pi times 7. Remember, with multiplication, we can do it in any way we like. So we can do this as equal to 2 times 7 first. And so we can call this 14 pi, okay? So remember, this means 14 times pi, and that's what 14 pi means. But 14 pi is just the way we write it. And because pi is irrational, it doesn't matter what we multiply it by, it will still be irrational. So if we multiplied this out and we wanted to write it down as an actual number rather than something times pi, then we would have to round it. So let me show you that. 14 times pi would be this. So if we wanted to write this down as an actual number, we would lose the accuracy because we would have to round this number here. We'd have to round it to somewhere. Okay, right, let's have a look at the next one. The area of a circle is given by pi times radius squared. Find the exact value of a circle with radius 5 centimeters. So we've got pi times 5 squared, which will equal 25 pi. This is the customary way to write numbers with pi. You always write the number part first, then you just stick pi at the end. Right, let's have a look at question 9. So 9 says the side length of a square is given by side length equals the square root of the area. The area of a square is 10 centimeters squared. Find the side length as an exact number. So that is just going to be root 10. Okay, and we will just leave it like that. We should put on the units though, centimeters. I should probably have actually added the units to these ones as well. So this would have been centimeters squared, and this one would have just been centimeters. Question 10. The diagonal of a square is given by diagonal equals side length times root 2. If the diagonal of a square is 10 centimeters, find the side length as an exact number. So what we've got here is we've got 10 centimeters, 10 equals the side length times root 2. Okay, right, so remember, this is going to be a rearrangement of this calculation. So if two numbers ever multiplied together to give a singular number, which we call the product, we know that the product divided by either two of these gives us the other one. Okay, so we sometimes think about this with 2 times 3 equals 6. So therefore 6 divided by 3 will equal 2, and 6 divided by 2 will equal 3. Okay, so when two numbers multiply together to give a product, the product divided by either of the other two numbers gives us the other one. So in this case, we've got side times root 2 equals 10. So therefore 10 divided by root 2 will equal the side. And that is our answer. So the side is 10 over root 2, and that will be centimeters. Okay, I'll just say side equals here. Okay, so the side equals 10 over root 2 centimeters. Right, let's have a go at the scenario questions. So here we go. Question 1 says, a square floor has sides of 10 centimeters. A square floor tile even has sides of 10 centimetres. The diagonal is root 200 centimetres. Can the builder measure this diagonal exactly with a ruler, or is it an irrational length? Okay, well, let's see. We've got root 200. Let's try it on the calculator and find out what happens. So square root 200 equals 1.14213562. No, can't measure exactly. Irrational. Oh, sorry about that. I hid what I was writing with the calculator. Okay, so here we go. Question 2. Question 2 says 3 running tracks are measured. Track A is 400 metres. Track B is 200 plus 8 pi metres. And track C is 100. Track C is 150 metres. Which track length is irrational? Well, the answer to that is track B, because it's got pi in it. This must mean that we're never really finding circles with rational areas, because all circles always have pi in them somewhere, don't they? So therefore, whenever we find the area of a circle, it's probably never going to be rational. Right, anyway, question 3. Gardener designs a square lawn with an area of 40 metres squared. The side length is root 40. Is this a rational or irrational measurement? Okay, let's find out. So 4 is a square number, but I don't think 40 is going to do it for us. So here we go. Nope. So there we go. So we've got that here. I'll write this down. Root 40 equals 6.32455532. It looks like there was almost a pattern with the 3 5s, but no. Irrational. Okay. No. It is irrational. Okay, right, question 4, what we have here is we've got a scientist records 3 results from an experiment, 2.5, root 3 and 6. Which value is irrational? Well, that is root 3. Okay. And then last one, a carpenter, well not last one, 5th one for this one. A carpenter needs to cut these lengths: 0.25 metres, 121 metres, root 121 metres, root 2 metres and 10 metres. Which of these lengths can he do exactly? Well, he can do 0.25 because we can see that that is a rational number. Root 121, okay, he's been tricky. We need to recognise that that is 11 metres. So he can do that one. That is fine. The next one he can do is the 10 metres. He cannot do root 2, as root 2 is an irrational number. Okay, so last set of 5 here. So what we've got for these scenario questions, question 6, is it says a square coaster has a side length of root 60. The perimeter of the square is given by perimeter equals 4 times side length. Find the perimeter of the coaster. Give your answer as an exact value. Okay, so the side length is root 60. It's 4 times side length, so it's going to be 4 times root 60. Now the way that we'd just write this is 4 root 60. Now if you have a fancy calculator, it could be that this is going to be simplified even further for you, because you don't need to be able to do this, but basically this is equal to 4 times 60 is 4 times 15. Okay, now we can actually get the square root of 4 here. So what we can do is we can think about this as 4 times the square root of 4 times the square root of 15, and that is equal to 8 root 15. Okay, but that is a skill that you're not going to need for Foundation GCSE. It was just something that I just did to explain the number on your calculator if you type this into your calculator and did get 8 root 15. Okay, if you go on to do higher GCSE, this is definitely part of that. So that's something you'll find in that curriculum if that's something that you go on to. But otherwise, we do not need to know how to get to there from our for Foundation GCSE. So this answer here would have been fine as our exact answer. Okay, right, so Question 7 asks for, it says, a circular pond has a radius of 3.5 metres. The circumference of a circle is given by circumference equals 2 times pi times radius. Find the exact circumference of the pond. So we have got 2 times pi times 3.5. Okay, well 2 times 3.5 equals 7. So the answer to this is 7 pi. Because if we did it any further than that, we would get an irrational number, which we couldn't round accurately. Well, we could round it accurately, but it would always be rounded, so it would never be the true value. Okay, right, question 8. Question 8 says, a circular pizza has a radius 6 inch. The area of a circle is given by area equals pi times radius squared. Find the exact area of the pizza. Okay, so we've got pi times 6 squared. 6 squared is 36, so this can be 36 pi. And there we go. And that is square inches. And that makes sense because pizza is always measured in inches for some reason. Okay, right. Question 9. A square patio has an area of 20 metres squared. The area of a square is given by area equals side squared. Find the exact length of one side. 20 equals side squared. Okay, this is kind of testing a bit of our other knowledge of knowing how to go from square numbers to square roots. Okay, so if we want to undo something squared, okay, the way that we get this, if the area of the square is 20 and we want to unsquare the side, we're sort of taking the square root of both sides, and getting the square root of the side eliminates the squared. So the side, in this case, will just be equal to root 20. Okay, there we go. Now that's an irrational number. It is a number that could be simplified. If you've got a Casio class whiz, it might be telling you that this is equal to 2 root 5, because 20 can be rewritten as 4 times 5. Okay, and then we can rewrite this again as root 4 times root 5. And root 4 obviously can be turned into 2, which is where this answer would come from. But in the Foundation GCSE paper, you don't need to do all of that, so you don't need to worry too much. So saying that your exact value for your side was root 20 will be fine. Okay, right. Question 10 says, a square TV screen has a diagonal of 10 inches. The diagonal of the square is given by diagonal equals side times root 2. Okay, so what we've got here is we have 10 equals side times root 2. Remember, if two numbers multiply together to give another number, we know that we can get one of these numbers by dividing the product, which is the 10, by the other number. So in this case, side will equal root 2, 10 divided by root 2 inches. Okay, right. Anyway, there we go. That is all of those questions completed. I hope that was okay for you. If you struggle and you need any more work on that, there is a tutorial available on crackmaths. If you want any further questions, just let me know in the comments and I can do that as well. Have a lovely rest of your day and hopefully see you in another tutorial. So long, bye.